doing is we're going to be substituting. All right, so that means that you're going to have, most of the times, you're going to have one of the equations solved for a variable. All right, but again, two equations, finding a solution for, they are always an ordered pair. All right, so you got to find an x and a y. The next way we look at is substitution. It means basically, look, if you're substituting fries for fruit, right? We've all done that before. We don't want the fruit, we want the fries. Okay? So you're replacing it. That's what we're doing here. You have two equations. Most of the times, one of these equations is already going to be solved for a variable. Okay? So this is what y equals. Y equals x plus 1. So if I take what y equals and I substitute it for y in the other equation, then we have 4x plus what y equals. Okay, we replace this y with what it equals, which is now x plus 1, and that equals 6. We all understand that? That's kind of the crux of it right there. The rest of it is our ability to be able to just solve an equation. So we combine like terms here. 4x plus 1x gives me 5x plus 1 equals 6. We subtract the 1, and so we have 5x equals 5, so x equals 1. That's part of my answer. Again, remember, we've got to find an x and a y. So I'm going to take this value of x here that I have found, and I'm going to plug it in to one of the original equations. It doesn't matter which one you plug it into. The top one's nice because it's already solved for y, and that's what we're looking for. So we have y equals x plus 1, but x now equals 1, so y equals 2. Okay? All right, let's try it again. This time I want you to do it. I want you to take what this y equals, and I want you to substitute it into the other equation for y. Give it a shot on your own first. So now we're just going to go ahead and solve this. I'm going to distribute this 2 first. That gives me a negative 16x minus 6. And again, we still have this 5x, and we have this 5. Now again, this is just our ability to be able to combine like terms and solve an equation. So 5x minus 16x gives me negative 11x minus 6 equals 5. And by the way, for what you do for me in this class, none of your answers should ever be decimals. All right, so we're going to add the 6 to both sides. And this gives me negative 11x equals 11. We divide the negative 11, and x equals negative 1. So again, I have half of my answer now. We have to find the y. So I'm going to take this negative 1 and plug it back in here for x. So we have y equals negative 8 times negative 1 minus 3, which gives me a positive 8 minus 3, which gives me 5. All right, any questions? All right, I want you to try one more. Try the next one. All right, so just kind of the setup. This is what y equals. We replace it with y up here. So y equals negative 3x plus 1. All right, so we're going to go ahead and distribute that. What are we distributing? The negative 6, good. So negative 6 times negative 3x gives me a positive 18x. Negative 6 times positive 1 is negative 6. We have the negative 8x and the 4. All right, so negative 8x plus 10 or 18x is 10x. We add the 6 to both sides. So 10x equals 10. Divide the 10 to both sides, x equals 1. All right. Plug it in here for x. Y equals negative 3 times negative 1 plus 1. Gives me a positive 3 plus 1. Gives me 4. Now, this is really heavy with just trying to do equations, okay, which some of us still struggle with. And you can see here, I'm kind of limited on my board space here, but you can see here that there's a lot of work and a lot of possibilities for errors. So it's really, really important for you to do two things. Keep your work neat, and as best you can, keep yourself focused in the problem until it's done. One of the things that I notice about several of you is that you get started on a problem and then your attention goes somewhere else for a second. All right? And then all of a sudden, you try to come back to the problem and something gets messed up. Small mistake. Something you didn't understand the concept. You just didn't focus all the way through it until it was done. That's going to be important where you have problems with a lot of work like this. All right, the last thing you're going to have to do, let's try this one. Try this one on your own first. So this one, you can kind of go both ways with this. You can take what this y is and put it up here, or take what this y is and put it down here. So if I let this one replace this one, then I have x plus 3 equals 2x plus 5. Now, the idea is, of course, we're going to get all the x's to one side. All right? So, most of us, if you got to this place right here, decided to move this x over. Because we just like to have our variables in the left-hand side. So then you had 1x minus 2x gives me negative 1x plus 3 equals 5. And I subtract this 3 from both sides. Negative 1x equals 2. Divide the negative 1, and x equals negative 2. So we'll plug in this x. I'm going to plug it in here because x is by itself. So y equals negative 2 plus 3, which gives me 1. All right, now, you might have an x that is solved for. It doesn't matter whether it's an x or a y. If x is solved for here, we're not going to do this one, but I wanted to show you as an example. If this is what x is, then I'm going to replace it with what x is over on the other side. But the last two problems in your homework are going to be ones where you have to solve one of the equations for the variable. Okay? Now, in both of them, in one of these equations, the variable will already be without a number in front of it, kind of deal. So I have negative 5x plus y equals 1. I'm going to solve this one for y because it's really only one step. I just add this 5x to both sides. And so y equals 5x plus 1. So I just changed this. I didn't do anything with it. I just changed it so that this was now y equals 5x plus 1. It's the same equation. I just moved things around. And then I have 5x plus 3y equals negative 17. And now I can start the substitution process where I take what this y equals, I plug it in over here, and I solve. Okay? Do you guys have any questions?